Hi, this is Mrs. Zhu, and we're going to be working on homework 5, the proportions practice. And for number 1, when I read the information, it says that 2 out of 3 of her relatives live in Texas, and then Sherry has 48 relatives. And we're looking for how many of them live in Texas. How many live in Texas? Now, if I see 3 pieces of information and 1 missing piece of information, sometimes that's a good indication of using a proportion. Remember that the proportion is 2 fractions that are equal to each other, and that these fractions have relationships with one another. Like here, Sherry knows that 2 out of 3, which is actually going to help me create the first fraction, 2 out of 3 of her relatives live in Texas, meaning 2 are in Texas, and 3 is maybe the relatives that she knows. So 2 in Texas, 3 relatives. So if there's 3 people, let's say that these were 3 people, then here would be 2 of them in Texas. These 2 would be in Texas, and 1 of them would not be. Okay? Then we know that 48, she has 48 relatives. And do you think that 48 should go in the numerator like this and over x? Or should it be x over 48? Does 48 mean the people in Texas, or does it mean her relatives? Right, it means her relatives. So we're going to stick with that fraction. And here's my proportion that I've created. I can see if there's a relationship between 3 and 48, which there is by multiplying by 16. So if I multiply 12 with 16, that will also get me to my answer. X would be equal to 32 people that live in Texas. 32 relatives. Okay, or you can cross multiply. Okay, is this the only way to do it? No. You can find that 2 out of 3. Well, we'll stick with that for now. I'm going to let you try number 2 by yourself, and I will do number 3, and then I want you to try 4 by yourself. Actually, I want you to try number 3. Let's try number 4 together because it does have the shapes, and in case we don't remember, I want to explain that to you. Here our key word is the first sentence where the word similar is there. It's telling me that these 2 are similar, meaning if they're similar, then what I see is that angles that correspond would be equal, will equal each other. Okay, so here's an angle E and angle A. These 2 are equal to each other. So if they're 120 degrees, then this would also be 120 degrees. I'm just making a guess, really. Okay, similarly, C is an angle that's the same as angle G, and the angle B is the same as angle F, and angle D is the same measure as angle H. Okay, so that's what makes them similar, as well as their sides. The sides that correspond we consider them to be proportional. So if one side is 40, this side of the parallelogram, then EG over here would be proportional in length, as well as the CD at the bottom is proportional and corresponds with GH over on the other smaller parallelogram. Okay, so that's actually going to help us to set up our proportions, because what you'll see is that these 2 numbers will make a fraction, and these 2 numbers over here will make a fraction. Now, I'm looking for the length of EG, and EG is this length right here, my X. So these 2 will also make a fraction, and then I can make them equal to each other, creating my proportion. So my proportion is very simply 40 over 24 equaling X over 18. If I simplify my fractions, I do not, no cross canceling, okay, but I can simplify 40 and 24 because that's a fraction together. So if I simplify that, I would get 10 over 8, which is the same as 5 over 4. I'm dividing both by 8. That's what I'm doing to get 5 over 4. And that's equal to X over 18. So you'll see my fraction like that. And then I can cross multiply if I want, like that. 18 times 5 is going to equal to 4 times X 18 times 5 is the same as 90, equal to 4x. And then I'm going to divide the 4 with the 90. So 90 in the box, 40 outside, because the number on the top goes in the box. So I'm going to begin to divide. That gives me 220.5. So x is equal to 22.5. And if I label that correctly, it should be in inches because that's the measure of each of the parallelograms here. 22.5. And number 11, 12, and 16, I see some similarities between these three questions. And the similarity is that they're each asking me, it's a type of percent problem. And I can use a proportion to set that up. I can use percent over 100 equals is over of. So I'll do that for number 11. Giving me 40 over 100 is right here. I'm going to highlight that is what number. And I have the of 60. And then I have my 40% right here. So I'm able to see that my is the x, and then my of is the 60. I want to simplify the 40 and the 10 and get 2/5, so my number is smaller. And then I can see a direct relationship between 5 and 16, which if I multiply 5 by 12, then I get 60. So I can multiply 2 by 12, giving me the answer 24. For my missing piece. So that is my answer. I don't have to solve it this way, but I am going to show you the easiest one to take. Now, if you wanted to use an equation, then I would write 40%. I would change that to a decimal. So this is me showing you how to do it by writing an equation. It would be a good practice to do that. That would make 0.4 or 0.40. We can keep it 0.40. Of 60, which means of means to times. So I'm going to use a parentheses, and I'm timesing 60, so the 60 goes in the parentheses, and that's the is going to be my equal sign. Is what number? So what number represents the x? If I multiply the 0.40 and the 60, the answer that I'm going to get is 24. So if I do that, 0.4 times 60 is 24.0 with a decimal here. So you see that I get the same answer. Do that for number 12 and 16 if you can, using either the proportion or using an equation method to help you do that. Number 14, I'll help you with that one. This is what we've been just covering in class with an equation. And really the three key things is knowing of means multiply, that is means equal sign, and that if I see a what, then I'm able to use an x. Those are really the three key things that you really need to know. Oh, maybe a fourth one. If you see a percent, usually we want it as a decimal. So those would be like the 4 key things you need to know. So here we have the sentence, 15 is what percent of 60? So you just take every word, every number, and write an equation. 15 would be, I write 15. The is an equal sign, so I write 15 equal sign. What percent should be your x, okay, or we like to say x over 100. And my of is my multiplication sign, and then 60, and then I write 60. So the closest equation to that here would not be C or A. BD, the difference between B and D is, well, D says 60%, but I don't have any 60% here. I'm looking for what percent. So they wrote it as an x, which would actually be the answer I am looking for. So x can be as a fraction or a decimal, represent as a percent. Here, as I complete the chart, let me show you the triangle that we've been talking about in class. Please have this copied down, and why don't we spend some time copying it again for practice. I put my fraction on the bottom, decimal on the left, percent on the right. How would I change a decimal to a percent? I would move my decimal 2 to the right. I'm going to abbreviate here just a little bit. And then if I wanted to go backwards from a percent to a decimal, then just like I'm going to the left, I would move my decimal 2 to the left. That's really important. Okay, and then let's say I had a fraction, how would I change that into a decimal? I would divide it. I would divide that decimal, making sure that I put the top in the box. Okay. If I wanted to go from the decimal down to a fraction, I need to remember the place value of that fraction. Okay. And then from a percent and a fraction, the way that they are related is actually because a percent is over 100. So if you can create your fraction and make it over 100, then you're able to make that a percent. Do remember that anytime you go down to a fraction, that it should always be simplified or reduced. Simplified. Okay. And let's say I don't know how to make the fraction, the denominator at 100. I could always go around. I can always divide the top box into the box and get a decimal, and then go this way and move my decimal 2 to the right and end up at a percent. So I don't always have to go that straight route if I can't do that. Okay, so I would copy this down and to help you fill out your chart, either somewhere in your foldable if you have not done so, on a separate sheet of paper, always looking at it, copying it a few times. It would really be helpful. So in here, if I take this fraction and change it to a decimal, then it says that I could divide. So I'll divide that. Divided by 100, so the number on the top goes in the box. I get 0.01, so 0.01 is my decimal. And to change a decimal to a percent, now in my triangle, I remember that D was on the left and P was on the right, meaning that I should move the decimal 2 to the right. So if I move it 1, 2 to the right, I get 1%. And actually, if I look at the fraction 1 over 100, actually I remember that a percent and a fraction are related to each other by the percent being over 100. So 1 would be the percent. So it would be helpful, I guess, if I looked at all of these fractions and made them 100 in the denominator. 100. And could I do that with a 5? Could the 5 become 100? Yeah. I could multiply by 20. So that would be 20 in the numerator. 10 would multiply by 10 to be 100, so I can get 10 in the numerator. 20 times what would get 100? 5, that's correct. So I could put 5 in the numerator. So what you'll see here is actually, even from a fraction, I can jump over here to a percent, giving me 20% for number 19, 10% for number 20, and 5% for number 21, because all of these fractions I've turned into a fraction with a denominator as 100. Okay, then I can always work backwards from the percent to a decimal, and I don't always have to move in a specific direction. Go ahead and you try that by yourself. And I'm just going to fill out a few extra ones to help you out a little bit. Maybe the last one is a little bit tricky. If I have a percent and I want to change that to a decimal, then I'm moving backwards by moving that decimal 2 to the left. So wherever that decimal already is, you just move it 2 to the left. Here, I move it right here, decimal, and I happen to add 2 zeros, giving me 0.005. I do want to make sure that I drop that percent, and I know I didn't mention that before, but decimals don't have percents, but the percentages should have that percent, so it feels a little obvious, huh? Okay, and then if I wanted to get a fraction here, I could look at the decimal and get a place value. Okay, I can get a place value, or I could take this decimal and put it over 100. I just need to make sure that if I write 0.5 over 100, that I don't write 0.5, but I move that decimal once to the right, which means that in my denominator I also have to move the decimal once to the right, giving me 1 over 1,000, which is really the same thing as the decimal 0.005, the place value that the 5 is in. The place value that the 5 is in the thousands place, so that would be my fraction 5 over 1,000. Now I do need to make sure all fractions are simplified, so I'm going to divide both numerator and denominator by 5, and I'm going to do that over here, giving me the answer 5 divided by 5 would be 1. 1,000 divided by 5 would give me 200. So my fraction would be 1 over 200. I know it's a little messy. Let me just box that for you so you can see it clearly. And work hard on your homework, and please let me know if you have any questions.